cube. Now, before starting this derivation, let us first learn some amount of maths which is required to derive this formula. So let me go to the next page, then I shall come back to this page and we shall do the derivation. Okay, so let me go to the next page here where I am going to talk about integration which is required for this derivation. Normally, teachers complete the integration in the standard 11th itself and the maths is followed. But I am a kind of teacher who would do the integration for that particular topic and for that particular year so that it is easier for you to actually apply the integration formulas. Now, yesterday in the video, I have already told what is the meaning of integration. Integration is nothing but summation of small parts. When you want to add up small parts, you have to do overall integration. For that, we have a formula. Okay, the formula for integration is, this is the symbol of integration, x raised to n dx. Okay, you can even write r raised to n dr. Okay, the variable is the same as you can see. Now, whether it is x raised to n dx, the answer of the integration is n plus 1, x raised to n plus 1 upon n plus 1. Here it is r raised to n plus 1 upon n plus 1. Now, some of you may not be quick enough to remember the formula n plus 1. You have to just create your own trick. Now, what is the creation of the own trick? We will do with one example. Example, r, if I simply write r, it is r raised to 1 dr. What is the power of r at present? 1. So 1 plus 1, power plus 1 upon power plus 1 is the answer. So what is my answer? R raised to 2 by 2. Okay. X raised to 2 dx. I am using two variables. Now what is the power here? 2. So what should I write here? The variable is x. Power plus 1. So 2 plus 1 upon power plus 1. So 2 plus 1. So what is my answer? X raised to 3 upon 3. So what I have to remember, write the variable, write the power plus 1 divided by power plus 1. That is the formula I have to follow for any integration of this kind. Suppose the power is negative, r raised to minus 1 dr. Power is negative. You can also write it as integration 1 upon r dr. Both are same. Whether I write r raised to minus 1 or whether I write it as 1 upon r. What is my power? What should I remember? Write the variable. Variable is r. Then power plus 1 upon power plus 1. So what is my answer here in this case? R raised to 0 upon 0. Okay, so this is answer is 0 itself. Fine, it is r raised to 0 upon 0. So anything raised, or you can even say it as undefined. Fine. Okay. Now next, because it is divided by 0, undefined. Next, let us take r raised to negative 2 dr. What is my integration here? 1 upon r square dr. Okay. So whether this or this, both are same. Now what is my way of doing, or what is my trick of doing? Write the variable. Write the power plus 1 upon power plus 1. So what is my answer? R raised to negative 1 by negative 1. Now like this I cannot put it. So I have to put it in proper format. Here I have written r raised to minus 1 is 1 upon r. So let me write it as 1 upon r. And negative here is there, so I write it as negative. Clear? So whether I have a positive power or a negative power, my trick is write the variable, write the power plus 1, divide power plus 1. And then finally I have to put it in a proper format. Also one more negative example we should do. R raised to minus 3 dr. Okay. So what should I do? R raised to negative 3 plus 1 upon negative 3 plus 1. What is negative 3 plus 1? negative 2 upon negative 2. Now I have to write it in the proper format just like this. So r raised to minus 2 can be written as 1 upon r square. Negative, I'll take it. And 2, I'll write it here. So what is my answer? Negative 1 upon 2r square. Clear? So, this is the formula of the integration we are going to do just now in our derivation. Now, other than this, once the integration is over, I can even apply the limits. Now, what are the limits? What is the meaning of the limits? Suppose this limit is, I write it as 0 to 2. That means I am summing up. What is the meaning of this? I am summing up from 0 to 2. Correct? I don't want the other values. I only want to sum up the part from 0 to 2 scale. So what I should do here? I have to finish my integration. I have finished my integration and then I have to apply the limits 0 to 2. So what is the meaning or how should I apply these limits 0 to 2? Instead of the variable, I write this upper limit 2 square upon 2 as it is minus lower limit 0 square upon 2. So what is my answer here? 4 upon 2, or simply I can cancel this because it is divided here. So 2 and this is 0. So my answer is 2. Agree? So what are the two steps? First integration part and then applying the limits part. How should I apply this? One example only I have given you. How should I apply the limit? Upper limit minus lower limit. What should I do in applying the upper limit? Just put the upper limit in the place of variable. I have put 2 in the place of r. Solved it. Minus 0 in the place of r. Solved it. Whatever answer I get, that is the limit I have applied from 0 to 2. Correct? So, remember this as a curriculum itself from now onwards in physics of class 12th. Whenever there is an integration, use the formula variable raised to power plus 1 divided by power plus 1. Then if limit has to be applied, upper limit minus lower limit. What is the meaning of applying the limit? Just substitute the number in the variable place and solve. We will use it just now so that you will also be very clear with what I am trying to do. Now, take a pic of what we have done just now so that all these examples you can revise and understand in your way. Self-study is the best study. I'm just moving. You take a pic. Then we will go back to the derivation. Okay. So now we go back to the derivation of potential due to a point charge. Okay. Now, where is our point charge plus Q? So, it is very important for you to draw the diagram